last thing I'd like to discuss here is the domain and range of inverse functions. Now, one thing to understand is that the inverse of a relation swaps the domain and range because they swap the x and y values. This means that the domain of f at x is equal to the range of f to the negative 1 at x, or the inverse of that function, and the domain of the inverse is the same as the range of f at x. So as long as you remember that they swap, it should be a pretty simple approach. So the strategy in order to get the domain and range of the inverse is, first you're going to get the domain and range of the parent function, otherwise known as the f at x. Then we're going to swap the domain and range for f to the negative 1 at x, or the inverse function. So whatever the domain was of the parent function will now become the range of the inverse, and whatever was the range will become the domain of the inverse. Let's look at an example and see how this works. So example 1, list the domain and range of the following function, then find the inverse of that function and list its domain and range. So the first thing we're going to look at is the domain. Now, there are no other restrictions listed here, so we know that the domain is going to be equal to all real numbers. However, the x cannot be negative 2. Why? Because that would give a value of 0 for the denominator, and you cannot divide anything by 0. So we're going to say that x is all real numbers except negative 2. So when we write it here, we can write this in different notations. One possible notation is as follows, where it approaches negative infinity, so all real numbers with the exception of negative 2. And from negative 2, union, it can approach all numbers with the exception of negative 2 towards the positive infinity. Now, in this case, we would normally have enough information for the range as well, but we're not actually given enough information to properly determine the range unless we graphed it, and then it would just be all real numbers. So what we're going to do is we're going to head to this part of the question. We're going to find the inverse function. We're going to get the domain of that, and that's going to equal the range of the original parent function. So like we did previously, we're going to swap the y and the x. So it's going to be x is equal to 1 over y plus 2. Then what I'm going to do to solve this is I'm going to put brackets around here and cross multiply it. And what that's going to do is that's going to give me x times y plus 2 equals 1. And then I'm going to FOIL out this bracket here, which is going to give me xy plus 2x equals 1. I'm going to bring as much terms as I can, I should say, to the right side of the equation so that I can finally isolate for y. So we're going to subtract both sides by 2x. I'm going to go xy is equal to 1 minus 2x. And then we're going to divide both sides by x as follows. And then our final expression is y minus 2x over x. Okay, so right away we can already tell our domain. The domain, x cannot equal 0 because otherwise you're going to get 0 as the denominator, and that is undefined. So x cannot equal 0. So what we're going to say for this one, when we write it in the bracket notation, is that it is all real numbers, negative infinity, except 0, and it approaches, with the exception of 0, all real numbers in the positive infinity direction. And this is key because then we can understand that this would be the domain, the range for the original function, since they simply swap places between the parent function and the inverse. Furthermore, if I wanted to get the range, of the inverse function, which is this function over here. And I'm actually going to replace it with f to the negative 1 at x. Then we can just write the domain of the original function, which is negative infinity with the, so it approaches negative infinity with the exception of negative 2. And we would normally write this in bold letters. I'm actually going to highlight them because they should be bolded. And then it also approaches positive infinity with the exception of negative 2. As follows. And so we found all the parts that we needed to find with this question. Let's take a look at one more. So for the first part of this question, we're going to find the domain and the range of the function as much as we can. So there are no restrictions listed, except that we know since this over here is equal to, or sorry, since this cannot equal 0, then we can write it as follows. So we're going to go x cannot equal 3, or negative 3, I should say. And that's because if I put negative 3 in for here, then you'll have an undefined, right? Negative 3 plus 3 gives you 0. So in interval notation, we can assume that it goes both in the negative and positive directions infinitely. So it'll approach negative infinity with the exception of negative 3. And we're using round brackets because these are not actually included points. This would be bolded. And then after skipping negative 3, union, that's what the U stands for, meaning we're uniting two sides of the domain. Then from negative 3, but not including negative 3, it's going to approach positive infinity. Now, we don't have enough information for the range, other than that maybe it approaches negative to positive infinity, but even then that's not specific enough. So what we're going to do is we're going to find the inverse of this and then get the domain of that inverse. And once we get the domain of that inverse, we know that it's going to equal to the range here. So using a bit of algebra, let's answer the next part of the question where we're going to find the inverse equation. So we're going to write, I'll write here, that y is equal to 10 to the negative 10 minus x divided by x plus 3. And then what we're going to do is we're going to switch the spots between all these x's and this y. So it'll be x is equal to 10 minus y over y plus 3. And now we're going to isolate as best as we can for y. Okay, so we have the inverse function here. It took some time to solve for it over here. I'm going to put wow. But we got the inverse function. So from here, we look at the denominator for the domain. And we can see that in terms of the domain, that it cannot equal negative 1. So if we're going to write this into interval notation, is that it'll approach negative infinity with the exception of negative 1. So that is not an included point, so we're going to use round brackets. And then from negative 1, but not including negative 1, it's going to go to infinity, at least with the parameters that were given here. And so these negative 1s are not included. Now, this is important because remember that the domain of the inverse is going to be the range of the original. So now we're going to go to the range and we're going to write negative infinity, negative 1, union, negative 1 to positive infinity. And the same is true with the domain, whereby we can say that the domain of the original function is the range of the inverse function. So then for the range, we're just going to go r is equal to negative infinity approaches to positive infinity with the exception of 3, so that is not included, and from 3, or union, negative 3 to positive infinity, but not including 3, of course. And so here is the domain and range for your inverse function, which is